All right, nice. Whole lot of people here. All right, let's check my sound. All right. What do you guys want to, oh, there we go. Add haircuts all around for me. It's all good. So what can I help you guys with? I can pull up Visual Studio. We can look at sample code. I think I even have the sample code that I did just before the exam. If you want to, let me do a screen share on this. What topics, you can throw it in the chat. What topics you guys want to go over? Because I have nothing in particular that I want to go over. I want to make sure that you guys feel comfortable with. We're not going over new material or anything like that. What kind of topics were you hoping to look into? We're looking at. Or do you want to just go over what we're doing in the assignment, which should have been done last night, but I know I extended the time just before the exam. File input and output? Yeah, all right. I love how much I write and how little you guys write. It's so to the point. It's very efficient. All right. I already got an example of this, but I'm going to just walk through it one step at a time. Let me give you the stupid looking text file I have. And I might modify this, but hello, how are you all today? That is my stupid looking text file. That's what I'm going to read in. Notice I'm not using commas in here. I'm using spaces, but I could use a comma. I could use a tab. I can use all sorts of other things. If I'm using white spaces and I know I don't have extra spaces in there, scanf, I should say, will allow me to pull off next field, next field, next field. But that I don't have that option for things like commas. Comma separated value files, I need some way of finding the comma and processing it that way. We have string tokenizers and a bunch of other things we're not going to get into, but either I need to, if I have spaces and new lines and stuff like that dictating when the next field is, it's something very different than if it's like a tab in between each field. If I don't care about fields and I'm just pulling off the text like I'm about to do, well, it doesn't matter if I have a space or a tab or whatever I have. So let's put a tab in here. It's going to work. Tab. All right. Looks the same, acts the same, but it's different. Okay. Here's what I'm going to do. Here's my file reading. I'm going to read in, here is the name of my file. So the name of the file, if I'm calling this thing, here it is, test2 text. Oh, I put a 2 in there, so it's not going to even work. There you go, test text. That was a test at the very end of what I was doing in the demo, just to be like, hey, by the way, if you don't know if this is working correctly, here's how you can show it. Putting a 2 in there, make sure that it doesn't match this thing right here, and then all things go to hell, right? That's good times. This thing is, I'm calling this function. This function has a variable called file name. File name is equal to text.text. But a terrible name, text. Texty text. If anyone knows How I Met Your Mother. Okay, so here I am. I have my variable, which is named file name. It is a constant character pointer. It's text, but I'm not allowed to change it. And I'm not allowed to move the pointer around. The text is what it is. That's what this thing is effectively saying. The name of this file, you're not going to modify, you're not going to change it, you can't modify or change it, and it is text.text. Okay. I'm going to make one of these things. There are a couple places where you have to sort of, memorize is not the proper term, put it on a cheat sheet, write it down, bring it onto the exam, right? One of them is the name of this thing that I'm going to read in. It's a file, and it's a pointer to a file, but that's what we write this thing here, right? It's a pointer to a file, but you can just write this for right now. And it's saying the file. I just need to do that. That's also in the FileIO lecture as well, by the way. And I want to figure out how many words I have in this thing. Maybe this thing is just counting the number of words. That's what the original plan is. So I want to make some place I can store text. When I read in the text, each word, I'm going to store it somewhere. I'm going to throw it in this case, a static array. I'm hoping to gosh, the amount of text I'm copying over is not more than 100 characters. If it is, I'm in some trouble. This is where I'm going to store, when I pull off some text from the file, I'm going to store it in this thing because, okay, this is me opening a file. So this is the safe version of it. Let me give you the not safe version of it. F open, and then I'm going to, so I have a file name, and you might think, well, isn't that so much easier to deal with? I'm sure there's something terribly, terribly wrong with this approach in certain cases, because otherwise they wouldn't have made the safe version of the file. But this is saying, I have this file name named my file. If this thing doesn't open properly, it's going to be equal to null or zero. This is something you're going to get very, very used to seeing, these null pointers. It's if I got nothing there, I'm just pointing random places. I'm pointing up. There is no actual position in memory where this thing is located. It's zero, it's null, it doesn't exist. I need some way to know when I have a pointer that's not set up properly. That's what null's for. Okay, so this would be the not safe, quote unquote, not safe version of it. This is the safe version of that same function. It's going to open a file, the file listed as this thing here, text.txt. It's going to open it up and read it in. Notice my text.txt. Let's see if I can plop up the properties for it. I'll do it. It's going to tell me where the location is. I had the location before. Probably just missing it. You for output text time. Yeah, I can always just look at it. So uh, I know exactly where this thing actually is located, but if you're wondering, okay. This thing, this text.txt, is located exactly in the same folder, using Windows Explorer kind of thing, in the exact same folder as my CPP file. It has to be in the same location if you're going to just use text.txt. Otherwise, you need to either give relative coordinates. That's saying go back 3 steps, go forward, down 3 directories, go over this way, go over that way. Relative coordinates are based on where I am now, where do you need to go to get the file you're looking for? Absolute coordinates are starting at C, what's the path to get there? Since none of you are going to have the same pathways where your project is or where this thing is stored, we're definitely not using absolute coordinates in this case. This would be one of those cases where if you're making a game, for example, or you have a game that you're installing on your computer, and it says, where do you want to install the game? It will keep the path from where you installed it, keep that as a string, and then just tack on whatever other folders to find the resources that it's looking for when it's looking for like images and stuff like that in your game. Relative coordinates are based off where this thing is running or compiling, where do I go? So in this case, it's the same location where the CPP file is. If I'm running from the command line, it's relative to where the exe file is located. It's a different place. And so the number one rule I normally have for this sort of thing is, here we go. If this thing doesn't open, so if the file opens, it's not going to be equal to null. So if it's equal to null, print off something to say like, hey, the file didn't open, dummy. Don't say dummy. Well, maybe you can say dummy to yourself, but I'm not going to call you guys dummies. You have some kind of message saying, look, the file didn't open. So you know right away, you're not going like, why isn't anything being read in? It says you can't find the file. I spent hours trying to figure out where the hell the file is or where how to find things. And so from experience, I just stuck my text file in the same folder as my CPP file and just be done with it that way. Because you're just going to spend hours of like, where's this thing located? So that's what we're doing. We're looking at the relative and the absolute paths are the same. It's the current directory where I'm running this thing. So it's going to open this file by calling fopen. And then in this case, I'm going to call fscanf. Why? Because I can. This is like scanf was in the earlier assignments, but instead of coming from the user, it's coming from a file, the f in fscanf. I'm going to stick whatever the heck was in the file. So here's the file that I'm reading in. I'm going to take in a string from that file, the next string in the file. It's always the next one. The next string in the file, dump it into this character array buffer, which has a maximum length of 100. And as long as that's not equal to 0 or some other negative value, because it could be end of file, which might be I think a -1, just keep on pulling off the next field. I made homework 8, Erica. So the question was, in the last email, you said homework could be delayed for a day or two. It meant homework 8, which is because it directly impacted the exam. But I wanted to not change the deadline, what they said, the due date for homework 8, because I knew what was on the exam. So it was, I know this thing ends up being on the exam, or a lot of this stuff ends up being on the exam. This is good for practice to get ready for the exam. So I don't want people putting off. I have a lot of students over the years that have tried to memorize their way out of programming. And I'm like, no, just do the work, and that's how it sticks in your head. I'm sure many of you still don't believe me, but every bit of evidence seems to suggest this, right? It's like math, the same thing with math. You cannot memorize your way out of understanding linear algebra. You got to do practice until you make it your own, until you understand it. So that's why the due date was yesterday, but I think the actual deadline is tomorrow night, but pass it in earlier. Just don't just pass it in earlier. I don't want you getting it shouldn't be impacting assignment 9, it shouldn't be impacting your other classes. It is purely just if people need a little bit of extra time or want a little bit of extra time, take it. But every time I extend a deadline, it means that people don't do it until the actual new deadline. And it just compounds the problem because now they don't have enough time for assignment 9 or their other classes. That's where the issue is. But okay. This is me using fscanf. I am reading it. I'm going to, here's me using fscanf. We'll do that one in a second. So fscanf, if I look at what this thing says, here we go. It says I have a file stream to start as the first parameter. The second parameter, according to this thing, is some kind of character format like scanf. So I'm going to put quotes and put whatever text what I'm going to read in next. I also happen to know that with scanf, you need to put in where this thing is going to go, and fscanf_s takes in the size of that array that I'm going to dump stuff into. It just those are the input parameters, either from experience or just looking it up online or whatever the case is. And also it tells me what to do when I hover over the field. Okay, so if this value is greater than 0, as in it, if it's equal to 0, I'm done. I don't have any more text to read in. As long as that's the case, what I want to make sure is I'm going to be keeping a certain number of words here, and I want some kind of assert. The only reason I have this assertion here is if I have an infinite loop, let's say, so this keeps on calling over and over and over and over again. It doesn't stop because I have a bug in my code. The number of words would go well past 200, right? It goes off to infinity. And so if I have this kind of assert, it says, okay, if something goes really off the rails, like you have over 200 words here, you're not expecting that, like make it 1,000 or 2,000 if you want to. If things go really off the rails, blow up so I know what the problem is, rather than having an infinite loop and not knowing where the problem is, because it just hangs, your entire program hangs. So this is the only reason for this assert. It is, by the way, if this is greater than 200, blow up because something terrible has happened. right? I want to know if something is wrong, how this is really bad. I want to know exactly there, then and there. Okay. And then all I'm doing is outputting that word that I've pulled off, yes, for giggles. That's it. Okay. Increase the number of words. Done. Assert. So the term assert in the English language, right? So an assertion is, I am claiming this to be true. I am claiming the sky is blue, or I am claiming I am this height, or I'm claiming this. An assertion is normally, it comes up, I use it in normal English language sentences in a weird way. I think a lot of programmers do. I assert that if you pass 1400, you will do fine in the BIT program, right? That's a pretty bold claim, but you're saying, I'm guaranteeing this, essentially. I'm making a claim that this is true. And if it is not true, blow up in my face. The idea of the assert, and so I can go for that. That's a good point to point out. I like asserts for, not everyone uses them. You won't see them in a lot of other places. I fell in love with them, and I'm hoping they're useful for you guys too. The assert is meant to be, let me see if a good example. The index I'm looking at, I here. Let me put this as an assertion. Here we go. It won't make any difference to what you're doing. Assert I is greater than or equal to 0. That is the kind of thing you would put an assert for. And you'd say, well, obviously it's going to be. You might think it's obvious, but I will also guarantee I have screwed up enough times where I've thought it was obvious and then something weird happens and I found out I was wrong. I did my math wrong, something happened, I have a weird bug in my program, and like the index, the number of the position in the array that I'm looking at is -1 now, which is not an acceptable value, which should blow up in my face because I want to know that problem. I do not want it. Or maybe what I want to do is assert I is less than text txt length, right? That also should always be true. The length of the position that I'm looking at right now should always be less than the length of the text. Or maybe I could put in I could put something like this: assert text len is less than 200. Why? Because if I have something really, really weird, like that string of text is like 400, the length of that string is supposed to be is 400, and I'm expecting it to be under 50, like the length, the names of our programs, BIT1400, ITech2100, all those. If that string that you're pulling off is size 20, you don't have a real course. Something really horrible happened. If something really horrible happens, blow up. Stop your program right there at that spot and point out where that happened. So the programmer, the person who actually can fix the problem, knows what the problem is. What you don't want is that going to customers. And so while I'm debugging, assertions work. If I convert to a release build, assertions suddenly get turned off. And every single one of these assertions, this, all of these assertions everywhere are never called. They're actually programmatically removed from the code. They're completely ignored. So that when your grandma gets your program, she never gets an assertion failure. Only the programmer gets the assertion failure. The one person who can fix the program finds out what the problem is and fixes it. They're there as a way of testing, normally for sanity testing of your code. We've been using them for like unit tests, right? I'm expecting this result. It's not the right way of using an assertion, but I'd be using it because it's easier than trying to teach you a whole lot of other things. But you should always be thinking about, how do I test this thing? What should always be true? If I pull in this string, what's the maximum length it could be? I want to come up with things that if I add these two numbers together, what should the value be? Make an assertion to make sure that that is true, so that if it's not, I got a bug in my code, I can go fix it. I can find it. So this assertion is not in a release build. It gets removed programmatically. You're not doing anything with an assertion. It doesn't calculate, it doesn't store anything, it doesn't do any part of your program really. It doesn't output any statements. It's just a sanity check to say, if this is false, blow up in my face so I can fix the problem. And in case you're wondering where this comes up, has anyone ever heard of Heartbleed? Maybe not. It's a bit old now. It's a bit old news, but it comes up in a whole bunch of different formats. An old Android bug that came up 10 years ago, where you could access outside of an array bounds. So you have an array of characters, values, whatever the case is, and there was a way to go past the end of the array and get the data, which means that you can be looking at other code, you can be looking at other data that you're not supposed to be allowed to have access to. You could do all sorts of other things. You want to make sure your code is never able to get outside of the array. Assertion. If it's outside the array, blow up because something horrible happened. Or I'm asserting that the file reads in. So I could have had, instead of this if else, I could have an assert p my file is not equal to zero, not equal to null. If it's equal to null, blow up because you didn't read in the file correctly. It's not very gracious, but it does the trick. All right, I want to go back to debug mode. Does that answer your question, Osman? Hopefully. It's a great question. Okay. Next up, this is reading in character by character or word by word to see. That would be odd. Very formal. So with this while loop, all I'm doing is word by word pulling off the next word from this file of text. So what I should be pulling off is hello is the first time I call this. How is the next time I call this? Are you all today? That's what I would expect this thing to do. I put all those things, and at the end, whatever you do, don't forget to close your file. Now, it technically can be closed on its own when you close your program, but don't rely on that. No. So when you're done with your file, you're not using it anymore, close it up. Because if someone wants to write to the file, let's say, I'm reading from the file and then I want to write to it later, or if I'm writing to the file and I want to read from it, I have access violations if I don't formally close it. It'll formally close when my entire program ends, but I want to close it when I'm done with this thing. Don't wait. So I pass in the file pointer, the same thing I had before when I'm done. And that has to be inside of this thing because, well, what if it doesn't open? If it doesn't open, you can't close it. So when I have it open, I call open, I check to see if it opened correctly. And if it opened correctly, then I can use it and then I can close it and then I'm done. All right. Let's do so let's see this in action first and then we'll jump over to the next part. Boom. All right. So here we go. And read in the first word, hello. Read in the second word, how are you all today? The number of words in total is 9. 1, 2, 3, 4, 5. Wait a second. Number of numbers in 9. Okay, that's a different question actually. Okay, so this thing, that's all the words that were in the text document, and then I close it off. Let's use the fgetS thing. It's going to be slightly different. And instead of number of words, it's going to be number of lines, but I'm going to keep the variable around same as it was. Okay, fgetS, it will take in, so we'll get a look at what the heck this thing says. It's putting something into a buffer, that character array that I have, this 100 characters that it has. That's how big the character array is. And here is the file I'm reading from. It's going to take a line, the full line, maybe including the /n at the end, but it takes in a full line. That's all it does. And at the end, I can see if it's going to return something in here, character pointer. That's what this thing says. fgetS returns a character pointer. So what I might want to do is something like while this does not equal null, or I could say is greater than 0. It's a pointer. Let's say not equal to null. I'm going to do that print off thing again, because why not? Line, that's going to be line. I'm just going to keep calling number words. Not the number of words technically anymore. It's the number of lines, but close enough. All right. And what I might want to do is assert words is less than 200 again. Sanity check. Sounds good. All right. Should be the same, doing almost the same thing. It's going to look slightly different. It's going to be the line that I had. Look at this line. Hello, how? Are you all? The giant space, because that's a tab, not a space. There's a format differently depending on what you're looking at it and how things are laid out. The same as in a Word document. All today, though, is one word with a tab in the middle. And so if I need to look at a line of text, like in their assignment where we had commas separating them, I can't use fscanf because it's not a space that's separating the words. I wanted a comma. I want something that's unique that says that's the end of this field. Otherwise, I wouldn't be able to have spaces in fields in Excel, for example. I couldn't put words in there. I need that to be, I want to have this formatting to know where the next field is, to be something unique in between each of the fields. So for comma separated value file, it's a comma, tab delimited text file, the tab in between each of the fields. But it allows you to know where the next one is without like, oh, but what if a space is being used for two different words, but they're meant to be together? So hello, how, one line. Are, next line. You, next line. All today, next line. Does that make sense what we're doing here? So we just did a full reading in line by line from a text file, which is useful for assignment 8 and assignment 9, because we can then take that text file, that line of text file, this thing right here, this text line, just throw it at one of our other functions. Maybe like extract fields, I think is what the name, no, not extract fields, whatever one of the other tasks is, task 2 or task 3, where we made a structure based on a line of text. That's the line of text. Make a structure. Once you have the structure, test to see if that student has passed bit 1400. You pass in the structure, see if they pass bit 1400. Done. If they pass 1400, do a printf statement. So there are a whole bunch of different stages, but they all sort of work together. Pull in a line with that line of text, throw it at the other function to get the structure. When you get that structure, throw it at pass bit 1400. All right. Yeah, just move on to the next line. This is just like here, throw it into another buffer, a text or whatever you want to call it, throw it and then make another structure. Sorry, the original assignment, which I was trying to make easier for you guys, was I passed in an array of bits of these structures, and then you had to put in all the different the various structures in there, and then afterwards, then you check to see if each of those structures, if anybody passed bit 1400. But no, we're just doing the one function. The more generalized solution is you make the structure for all the students, then you test for bit 1400. The reason I want to do that is because what if I want to test if they passed bit ITech 2100? What if I want to check to see how many students I read in? What if I want to check who has this student number? What if I wanted to use this for other things other than checking for bit 1400? If I separate my different tasks, that's a more general solution. That's what we're always ultimately aiming for because we're lazy and I don't want to have to rewrite that same code multiple times. But in our case, yeah, just grab the next line, make another structure, test it if it passed BIT1400. It's the easier solution, but it's not the general solution. The general solution is I save all those structures, then do whatever tests I need to do after the fact. All right. Did you guys want to look at strings and how we deal with strings a bit more? What do you want to deal with? So that was files. Unless you want to write to a file, we can do that as well. Let's write to a file. File, the out file, and I'm going to put a new out file. I'm just going to give it a name. Open as the out file, and then if I do X, it's read and write at the same time, and you will hurt yourself. You can do it, but it's just painful because it'll overwrite the previous version of the file, I think, if you use X, but it allows you to read from the file, but then you can write from it. It's hard to control. Keep them separate if you can. All right, so it's going to write to a file. And I want to say, and the out file. Oh, didn't do that for me. Damn it. All right. So both of them open up correctly. That's what we want, right? We want both. Oh, how do you move to the next line? Call it again. Call fgetS again, and you get the next line. It's a file stream. It's not the same place each time. You call it again, you automatically go to the next line. And if you don't believe me, there you go. I just kept on calling fscanf, and I got the next line each and every time. It's always just moves to the next point. The stream, because like a stream in a river, it just keeps going. Once you get past the first set, more water is coming your way. So water goes by you once, the next bunch of water is going after you after that. After that. Next bunch of water is going in after that, or going past you after that. Okay, I'm going to have this, and then let's do just for fun, F, print F. You can even do a, I think there's a safe version of this. Is there a safe version? Yeah, there's a safe version of this. I'm going to put it out to my output stream. And I'm going to put out text I'm going to be putting out. I'll put a new line in here. Notice actually something weird about the fgetS. I put a new line in here, right? But when I used fgetS, I automatically got the new, I got all the way to the new line, the /n, and that was still included in my fgetS. It's part of the string. So, okay, I don't want to do that part. I don't want to do this /n part. Otherwise, I'm going to have space. It's going to be double spaced. Okay, attach a text, and hopefully that's going to do it. This is just me outputting to a text file, and f close p file. So now I'm going to close out the file. All right. Let's see if I compile separately from running my code. I keep saying this. No one believes me. No one listens, but I'm saying it anyway, screaming into the wind. The reason I keep them separate is I want to know when I have, if it compiles correctly, then I want to run it. If I do it at the same time, it may not compile correctly. I may not know it didn't compile correctly, and I'm running old code. And I can spend hours looking for what the bug is and finding out it's just me making a stupid human error. All right. So let's that. All right. So again, notice there's an extra space in between each one of these because fgetS includes the /n, this new line character at the end. Oh crap. Okay. So in case you're wondering, existing item, see what I have in here. All right, that should do it. This is the brand new file that did not exist before right here. That's it. And maybe you don't believe me. Maybe you don't believe me. So let's try something here. Because I know you all think I'm a dirty, dirty liar. So let's do this. There we go. There we go. He's a liar. Okay. Run my code. All right. New code, new lines, new everything. In fact, when I call open, I wipe out the old version of the file, no matter what I do, no matter how much I want to not do that. It's going to wipe out my original file, whatever. If there was an existing file there before, it wipes out the old one, makes a new file name with that name. So that's something to be scared of. But notice it's no longer exactly matching the other one. It now has this next line, next line, next line each time. All right. What other things are coming to mind? If you want to look at how we find a certain character, or so here is, I'm going to test to see if two strings are equal to each other. This is one of the things you could do. So one of the things I was playing around with is I had a function says counting the number of numbers in a string. So this is one of the examples I was coming up with, which is I have this string gets passed in. I walk down my string every time I have a number instead of a character or instead of another other special symbol, I will increase the count. So I'm counting the number of numbers here. So in this case, I have the 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 characters. That's what it should return. And so the horrible but effective test would be call in a certain, make sure that this string gives me 9. Or I can just say the number of numbers is 9 and then see what it returns. But this thing should have 9 characters. I want to test in my head what this thing should return. I want to know what it should get. So when it's wrong, because it will be wrong from time to time, or at least for me it is, whenever the text is wrong, whenever the value is wrong, I can go, why am I getting the wrong answer? And I can go line by line to see what my code is doing. So this thing just counts the number of numbers. Here I go. I have a line of text that I'm going to go over. I have the number of numbers. I'm going to have to set it up to something. I'm going to have to initialize it to some starting value. And then I'm going to get the length of my string. strlen, you don't have to reinvent the wheel. Somebody already did it. You pass in a character array, and it finds the length of that string. It knows it's at the end of the string. Actually, let me pose this to you guys and see how many people are actually awake. How does strlen know when it reached the end of the string? I didn't have to say the size of the array. So how does it know I reached the end of the string? And I'll wait. Some of you won't know. I know you don't want to just brag or anything like that, but how does strlen work? How does it know it reached the end of the string? But how does it do it? How does it know it has reached the end of the string? There's no number in it. It's just an array of characters. That's all it is. So how does it know when it reached the end of it? It doesn't know even the length of the array. It just sees a bunch of numbers, essentially. Other than the slash being the other way, absolutely correct. That's zero. But yeah, that's how it knows. When it reaches that zero, the numeric zero, but we use a slash zero to indicate it's something special. When it reaches that slash zero, it knows that it's the end of the string. It's a special character to say, hey, I'm at the end here. It's a secret ninja character. You don't even see it when you look at the string, but it's there. That's how C strings, character strings, are special. That's why you don't have to pass in the size of your array and all this other crap. As soon as it gets to a zero, you know you're done. Nice. Thanks, Osmond. All these other people are all quiet. I think they're trying to learn by osmosis or something. I'm joking, but at the same time, a little bit of, I don't know what you guys are doing on the other end, so I'm always nervous that you're like trying to multitask and the like. It's just, no, don't multitask. Single thing at a time. The only way it's going to stick in your head. Okay, so I know I'm going to reach the end of my string. So I didn't even need this, but I'm going to do it. I did it anyways. I know I reached the end of my string by calling strlen. Okay, and I'm just double sanity check. Hey, by the way, this string is going to be less than 200. If it's more than 200, something horrible happened. That seems reasonable. Or I could put 2000 or something like that if I wanted to. If it's a 2000, then you're going through a book instead because just a string. Okay, here's my for loop. I'm going to start at 0. I'm going to go to text length, but not including text length. So 0 to text length is all the actual visible characters. The character at position text len and the index text len is that magic imaginary 0, that /0 at the end. That's what's at a text at text len. If you don't believe me, you can look at the code itself. All right. I'm going to check each of those characters, each character one by one. There's actually a function for this as well, I think, but I always forget the name of it. Let's see if I can come up with it. SDR is alpha, is it's normal, is what wide alpha, is it an alpha? So an alphabetical character is long number, I think would be another one of these things. Is lnum. Nope, that's just testing that thing. This is one of the problems with C. You get all these functions. You don't know how everything's connected. You don't know if it's for whether something is an alphabet or a character or not. But I can't just check to see if it's a new alphabetical character, because what if it's a question mark? What if it's smiley face? Well, not smiley face. What if it's question mark? What if it's the exclamation point? So instead, I'm just going to check to see if the character is the character 0, not the number 0. The character 0 is a particular value. I'm going to check to see if it's the character 9 or anything in between. We know that those are in a continuous range. That's why we looked at the ASCII table early on the string lectures, right? They all go in continuous ranges. So A to Z, lowercase, continuous range. A to Z, uppercase, continuous range. And it allows me to do stuff with the characters. I can check to see, is the character that I'm looking at greater than or equal to the numbers, the character 0, and less than or equal to the character 9? If so, it's between 0 and 9. It's one of those characters. We can even put a breakpoint in this thing and see this in action. So let's put a breakpoint in this thing. So if it's one of these characters, it must be a numeric character. And if so, increase the number of numbers that you've seen. Do that for every single character in your string. You're done. That's how we count the number of numbers that are in our string. So here is our string here. Bonus points if anyone can tell me what this 1337, without looking it up on Google, what that actually means. I'm not expecting anyone because it's ridiculous and stupid, but I love it just the same. All right, let's roll this thing. All right. I just compiled. I'm going to look at my code. Every time I hit one of these number of nums parts, let's see what we got. So by the way, I also want to point out, do we have an str copy anywhere in here? I might want to put one in there just to see, show that in action. Let's make a new function afterwards. Okay. Room numbers, something like that. We're going to play with that. Okay, so what am I going to do here? I'm going to, and that's going to be a bit more complicated. I'm going to go through this character by character. When I find a number, increase the count. That's the easier version of this. I'm going to compile it again. Check to see. Run it again. I have hit my breakpoint. I'm at my breakpoint right here, and I want to see the number of numbers is equal to 0. That's what I started with. Let's see what I is equal to. I is equal to 1. What is this thing? I can highlight it and hover over it, and it's 49. That's the numeric value of the character 1. The numeric value of the character 0 is 48. The numeric value of the character 9 is 57. 57 minus 48 is what? If I include that entire number range, I get 10 numbers. It's a range of 10 numbers, including the outside numbers. So the 57 to 49, that would be 10 numbers in total. You include 48 and you include 57, should be 10 numbers in total. All of them are in order. One is one greater than the 0 character. Right? This is 48. This thing here, the 1 is 49. 2 is 50. 3 is 51. They're all in continuous range. So if it's in this range, I'm just going to increase the number. Great. And I should, if I run this again, I can just through this. So this is me doing this step over F10 all the time. So my count is going to go from, it is currently 1, it's now 2. I check to see if it's a safe value. I check to see what I'm storing here. It's a space. Is that between 0 and 9? No, it's not. I jump that if statement. Go around again. I check to see what the next character is. The next character here is should be a 3. Check. Let's just do this. Great. Increases the count. Go around again. Skip. Increases the count. Go around again. I can keep on going. At the end, I should get 9. And what I can do is just, let it ride and see what happens. This is the test 20. The number of numbers is 9. Done. We check to see what would happen. What we might want to do is, if we're not sure about our code, we could do something like the following. Hi, everyone. Lead. All right, that's actually what that stands for. Should be no numbers. So I should get the value 0 in this next test. You just run tests. Test 2 is 0. Hey, great. Test out a bunch of values. Okay. This is, I have this string equals thing, or text equals. They are not exactly the same, but hear me out with this one. For comparing two strings, if I have something like hello and hello, they're equal to each other, but I can't just say if they're equal, like a double equals. It won't work because the character, what it's saying is the location where this string is located equal to the location where this string is located. That's not true. They're stored in different places. The characters might be the exact same, but they're stored in different places. So we have these built-in functions that can help us with this. One of those built-in functions, well, let's swap these around, is this one right here. This is string compare. String compare takes in two strings, and it works different than everything else we've seen, just to be a pain. It will compare text1 and text2, and whichever one comes first alphabetically or based on their ASCII values, you will get a different response. So if text1 comes before text2 based on the ASCII values, character by character, going character by character down these two strings, if this one comes first based on the ASCII value, then it will return -1. If text2 comes first based on the ASCII values, it'll return 1. And if they're equal to each other, it returns 0. So it's either one or the other, so you can see which it comes first. It's a negative or a positive, which comes first, that tells you which comes first. And then I have 0 for they are the same, which is different than everything else we've ever done, because normally when we say something is equal to 0, it means it's false. 0 is false in C. So here's what I'm going to do. I'm going to return 1 if it's true, 0 if it's false. We don't have a Boolean, by the way, in C. Yeah, it's weird. We don't have some way of saying true or false. We have 1 or 0, like on or off, right? That's why the little power bars and stuff like that have a 1 and a 0 and it's on or off. So if it's true on 1, right, it'll return 1. Otherwise, it's going to return 0. So if this is equal to 0, I want to return 1, as in they are equal to each other. Otherwise, if it's not equal to 0, -1, +1, whatever it is, they're not exactly equal to each other. And I just return whether they're equal to each other. This is equal to this. That should be true. This is equal to this. Should be false. It is, in fact, it is false. I'm going to put a breakpoint on this one. We'll see it in action. So what would you expect this strcmp to return in this case? Or I could say, instead of this format, I could do, let's do it a different way. Uh, whole bunch of ways you could do the same function. I just want to show another way. Let's see. Comp val, because I want to see it in action. I'm going to call this function comp val, and then I'm going to return comp val is equal to 0. That does the exact same thing as that function above. But instead of a ternary operator, I'm just saying, is it equal to 0? If it is, they're equal. This thing is true, return 1. Otherwise, it returns 0. The same thing. But so why do I want to do this? Because I want to see what the comp val is going to give me. I want to see what the value here is. So what comes first, hello or hello? That's the question. So let's find out. All right, I'm at my breakpoint. I'm going to go into my function if Zoom doesn't get in my way. Here we go, going into my function. So I walked into the function. I can even look at my call stack. I'm from main. I now went into text equals. This tells me the call. So I will jump from here to here, do this, then I'll jump back out again. I'm going to go a couple steps. Contacting me. Okay, let's go down a step or two. All right. What would I expect here? Text1 is equal to hello. Text2 is equal to hello. Which comes first? We need the ASCII table. Capital letters, capital characters, capitalized characters come first in the ASCII table. So what I would expect is a positive value because this is going to come before this. Be wrong. I always mix it up in my head. Computational value is equal to 1. All right. Meaning text 2 comes before text 1. If I was trying to figure out the alphabetical order of things, this comes before this in the when I'm trying to sort things. And I want to see, is it equal to 0? It's not equal to 0, so therefore it's going to return. This thing will return 0 because 1 does not equal 0. So it's not true, it's false. So therefore, I'm done. That one's a weird case because let me do another example because I'm gonna break things. There we go. Are they equal to each other? They are not equal to each other. There's a space in there. They're not the exact same strings. So therefore, this should not also be equal. This is another kind of test I would have, right? They're not going to be equal to each other, despite the fact that they're both hello, but one has a space at the end. And then, because I want to show this part down here. Let me just run it. All right. It's saying they are not equal. This test says not equal. Therefore, it's true. So these strings are not equal because one has a space at the end, the other one doesn't. According to this thing, strcmp, it's not going to give us these things are equal. That extra space changes everything. Okay, but let's do another approach here. So let's close that. I'm going to look at this part right down here. So let's comment this out. This should do the same thing as a strcmp thing that we had, but I'm going to do something slightly different. Okay, so you'll have to bear with me what the heck that actually means, but str says it's a substring. So if it is text 1, let me see what the code actually looks like. Here is, I'm looking in string, the first parameter, which is text 1. I'm looking at text 1 and seeing if text 2 is inside, is a substring of text 1. So doghouse, dog. Dog is a substring of doghouse. Concatenation, cat is a substring of concatenation. The word cat is in the string somewhere. That's what substring does, str. And it says the pointer, where it's located in the string. It's not saying the index, it's saying the location in memory. So it's going to be a big old number, but it's a pointer. We didn't want to get into pointers too much, but that's what it's going to be returning. It's going to be a pointer to this thing. I put my semicolon at the end, and then I'm going to do the other way around. So pointer 2, because I want to see, it's what I did in the last line here, though. Return subpointer not equal to null. And all right, so let me try and talk out this part because we're about to jump into, or we've already jumped into, pointers. Oh, I'm down 2 people, it seems. All right. If, let me see what this thing looks like. It's going to return a constant pointer. All right. This is seeing if text 2 is inside of text 1. This is seeing if text 1 is inside of text 2. If they are inside of each other, it means that they are identical to each other. And therefore, if they're equal to each other, that this substring pointer is not null, this substring pointer is not null, and therefore they are equivalent to each other. But I just want to throw that out there. I'm going to put this right here, and we'll run this, and then we'll stop because I think other people abandoned me. least I think we have. Yeah, only 3 of us. So what is going to happen here? I'm going to call this with hello with a space. I'm going to call the substring, get the pointer to it. We'll see this in action, and then go from there. All right, I'm on this line. I'm going to walk into my function. I'm going to go down. Substring pointer is null. Why? Because we're testing to see if text1, hello, has inside of it hello with a space afterwards. No, it doesn't. This is bigger. This is the superstring of this one. This is bigger than this thing. The other way around, though, will give you that value. It's the pointer, the address, see that 0x0073, that crap. It's the actual location of where this substring is located. It happens to be hello, the full word hello, at the very start of my string. It happens to be exactly the same pointer as this thing right here, 737B4C. And this thing is 737B4C. They're exactly the same. As a result, this thing, if they were both not equal to null, it would mean this is a substring of this substring of this, and therefore they're equal to each other. If you wanted to work around the fact that you might have to worry about that extra spaces at the front or the back, str is the way to go. Just check to see if it's equal to null or not. That's the way to do it. If it's not equal to null, it is a substring and you're fine. Okay. Does anyone have any questions? I lost half the people here and I don't know why, if I said something horribly offensive or something like that, but can I answer any additional questions that you may have? I have a TA meeting soon, but other than that, I want to make sure you guys are feeling comfortable with this. Sure. Go ahead, Osmond. Oh, uninitialized variable. How do we solve this? Initialize it. Sorry. Here we go. Let me see here. Let me see where I could give you an example. Here you go. That is what you had. And what you end up having there, though, is if I'm incrementing, so the number of numbers I found, there is no default value set in my variables. And so if I don't start it off at some value, it's just junk, whatever was there to begin with. It's just getting memory, but you haven't set it to something to begin with. So I need to make sure I set it to some safe starting value before I start using it. If I don't, what is some random value here, and then I increment it? What's the new value? I don't know. It doesn't start off at 0. It could start off at any value it wants. There's no rules for how variables are initialized, unlike in Java and a couple other languages where they always have a default starting value, 0, normally for integers. You don't have that in C. It's whatever the hell was there. And it's one of the challenges of C. Can I compile that? No, it won't let me compile. So what I need to do is equal to 0. Done. That answer your question, hopefully? So you just need to find that variable where it's declared, like here, set to some value. Any other questions? Nice. Fantastic to hear. I thought we covered a bunch of that stuff in the lecture, but I guess I'm not as clear as I think when it comes to that, because it always leads to cause problems. So yeah, just reading in the file, just doing a bunch of these will finally get it into your head. Also, the labs cover examples if you want more practice with it. All right, are we good? If we are good, I'm going to stop sharing and I'm going to stop and then I'm going to upload the video as soon as I can. All right. Thank you very much, everyone, for listening, and I'll talk to you later. Okay, thanks.